One of the problems that we have with our new project is we'll certainly have to redesign the equipment because we have product changes. So could actually the virtual design review help us in selecting the right concept from day one before we put it into production? And on top of that, we have seen in the past a tremendous benefit from going from 2D drawings to 3D drawings when we do design review. So we are expecting that we could see a similar advantage going from static 3D design to animated 3D design with actually a scenario representing the configuration of the equipment.
Well, I think we can be able to benefit from using a digital twin early on in the design review phase or in the design of new equipment by being able to see or apply movements to the early modules of the machine and the processes, and thereby be able to identify potential issues. Whereas today, usually we have the hardware and software actually running on the shop floor before we identify these issues. If we can do that early on, we will be able to save time and money.
Our role is really to help the end user and the machine builder to communicate more effectively. So building the model, being able to send the model back and forward between the end user and the machine builder, being able to see how the functionality works, both mechanical but also automation-wise, gives a huge flexibility. So we can look at start with the design of the layout to see how the machine will fit into to the layer in the building, how we can optimize the productivity between the operators. That can be looked at the first phase. Then we can look at the functionality, the functional specs with the machine. So we see the functionality works as it should be, and we avoid having these huge mistakes or major faults that we have seen in the past.
One of the advantages we have already seen using the digital twin during the design review is that it helps the process engineer to understand and analyze the process more deeply, spot on potential area of improvement and changes. On top of that, it is a very powerful communication media to communicate process knowledge to all the process team and even abroad to the operators and the technicians.
SVM designs highly tailor-made assembly equipment with complexities and uncertainties being a risk to the projects. To some extent, it's the charm of what we do, but of course we are very interested in reducing the risks for us and our customers. I feel quite confident that utilizing the digital twin as an active part of the design review will become a huge advantage for all parties. Imagine if the digital twin was an active part of the design documentation. I have here the design specification for this project, where the digital twin has been made after the design phase. The document is a flat piece of paper with text and illustrations trying to communicate what we intend to build. Imagine if we added the digital twin to this. Imagine if a drawing like this was added a digital twin and the reader of the design specification could dive into multidimensional details in the digital twin. The 3D model from our CAD system could be used as it is already, but it doesn't contain any movements, for instance. It doesn't contain the assembly process, and it certainly doesn't contain the interactions between different modules as an easy thing to understand. All that is included in text and illustrations today, but imagine if we had the digital twin to support the design documentation.
First of all, by traveling, just the time that we use for traveling back and forwards between the OEMs and the end user is wasted time, because now we have the digital model that we can send back and forward in a mail format, and you are able to see how the model fit together. So in that way, it's reducing a lot of time spent, and it helps us be more effective in our daily work life.
It's a journey, right? It's a journey that we've just embarked upon. And one of the things will probably be when we have new products with a higher design risk. In those cases, we would probably be better able to investigate the design on a higher level than what we have done before.
By implementing the digital twin from the initial stages of a project and using it actively as a design and communication tool, we'll be able to contribute to the optimization of time to market of a new drug delivery system. Take for instance the testing of software, and imagine that being done up to a level of 60 or 80% on a digital twin, maybe even more. Those 4 to 10 weeks of machine time on the shop floor can be eliminated. Not to speak about all the needed test materials for activities that could have been done with the digital twin.
Now we have the opportunity with the digital twin to put in kinematics directly on the machine, so we have the full picture of the machine, both mechanically and also automation wise.